So if we look at the database here, this is just an absolutely normal database configured out the box. And if we look at the background processes for the database running in standard mode, these are all the background processes that we know. We know there's a PMON, there's a PMON, log writer, checkpoint process, system monitor, all the usual background processes we've got. And how many are there in this 12C database? Well, in crude count, about 50 odd background processes. And that's because we're running in the normal mode. Now, I did run a little program just to get an idea of performance improvements. And if you look at this program, all the shell script is doing 20 times log on, log off. I just want to get an idea of how long it takes to establish sessions against a conventionally configured database. If I time it, and we see the logons going through, and it looks that it's taking about a second for each of my 20 logons, but we'll get some figures coming through at the end. I do like to run these scripts twice just to make sure we get repeatable results. Now, how long has it taken? That was a total of 28 seconds. I'll just run it again. That's slower than usual. I'll just run it again to let the figures stabilize. It wouldn't be too fair on the system to go by an exceptional result. So 28 seconds. We'll try again and see if I get a similar result second time. And then I'll make the change. Now the change, done with the parameter. There's a new parameter, threaded execution. If I set that, alter system set, threaded execution, default is false, and set that to true. It is, of course, a static parameter. Something as drastic as this can't be done on the fly. Well, 28 seconds, I'm getting consistent results. So my 20 log-ons, log-offs are taking 28 seconds elapsed time. Then I'll restart the instance with threaded execution. Now, remember what was happening at the operating system level. We had a total of over 50 processes. Well, it's not like that anymore, is it? My 50 processes appear to have come down to 1, 2, 3, 4, 5, 6, 7, to just 7. Just 7 processes. We'll see what's going on within these 7 processes in a second. But you can see already, reducing 50 processes to 7, there's a dramatic change in the entire Oracle architecture as we do that. I'll just, pardon me. There's a bit more to it, by the way, than just setting one parameter. I should confess I have done a bit more preparation than that. Now, to run the oh, I didn't enable the timing. Right, now we get an idea of what's actually, ooh, that's not bad. So my 28 seconds has come down to 16 seconds with the threaded server. I'll just run it again to see if I get consistent results. And what you can see going on here is that all of these processes are in fact in one process, process 3263. So ps minus ef grep orcl. Right. This process 3263 is in fact Aura U005, and within that one process, all these processes are running as threads. All these processes are running as threads in 3263. So our just to pick some of them out, oh, you can see further up here our checkpoint process and our log writer process. There's my log writer is part of process 3249, checkpoint process is part of 3249, SMON is part of 3249, they're all separate threads within, in that case, 3249 within that process. 15 seconds. So running my little script through the conventional server took 28 seconds. Running it through the threaded server took 16 or 15 seconds. I've doubled performance, And remember, that's a very crude example. You know, all I'm doing there is just logging on and logging off. Just doing that and that. But to have doubled performance just for that one part of the cycle is going to make a terrific difference.
Pardon me, John.
Yeah.
Just a couple of thoughts and a question. To the audience, just to recap what we've just seen here, we're seeing a 12C solution. And I think John's going to summarize this for us again, but this is unbelievable. I've not seen this demonstration before, so I'm very impressed myself here. And you turn this on with threaded execution equals true, correct?
That is correct. The basis of it is just one parameter. Now, there is a bit more going on. There are some network issues. For example, I've got a problem here. You have to go through SQLnet. So there's a bit more going on in the background than one might think.
I've got you. Now, this log on, log off business, if we don't have 12C, are we saying, okay, this is a bad practice, one to be watched for? I mean, going back to your point where you were saying, these are high probability of problem areas. How do we solve this if we don't have this 12C multi-threaded feature?
Right. That's what we'll come to. Previous slide. The issues then is a high log on, log off, which I just demonstrated, and also the high proportion of idle sessions, which I haven't demonstrated. Because even those idle sessions, 1,000 users running forms, at any given moment, probably only 10 of those 1,000 sessions are actually doing anything. That's the other problem, many, many idle sessions. They're not idle as far as the user is concerned. They're idle as far as Unix and the database is concerned. Now, this 12C solution, I think, will fix both of them because all of the user processes get summed up inside the multi-threaded server. And as you've already seen, the actual log on, log off is very much faster. But I shouldn't be spending any more time really talking about 12C facilities. What I want to go on to now is how we can get a very similar effect with 11G, a very similar effect. How we can fix the problem right now.
John, I've got to throw a couple of more at you though, because I can see our students are chomping at the bit here to get a couple of questions in. Any word on whether this threading option will be backported to 11G?
I've heard nothing about that, and frankly, I would think it would be architecturally impossible. What I suspect is that this has only become feasible because of recent advances in the technology, advances in the C compilers, advances in operating system. I don't think there's any way it can ever be backported.
Very good. This is obviously a 12C feature, but is it available with Standard Edition, or is this only an Enterprise Edition, to our knowledge?
I can't answer that question. I'm sorry, we'll have to do that offline.
Very good. Thank you, John.
Okay, so what can we do to fix this problem right now? Because we can fix it. We can fix it. With an ideal world, I as DBA don't have to fix it because the programmers do it with connection pooling on the middle tier. Now, that would clearly be the optimal solution. But if that hasn't been done correctly, then I'll run through what I as DBA can do to fix the problem. Middle tier connection pooling is, of course, best. Just tell your programmers to do it. Any decent Java container, such as the one we work with usually is WebLogic nowadays, and before that, Oracle Application Server, OC4J, but any decent Java container should be able to do middle tier connection pooling. OCI applications have been able to do it as well since release 9. However, there are some issues. The first one, of course, is that your programmers have to enable it. But apart from that, there are sometimes issues with maintaining session state. Where's the state of the session going to be maintained if you're sharing connections through a pool, tuning the pool? We can assist with all of these. But in principle, this is your programmers do the work. What if your programmers haven't done it? Well, now we can move on to the database administration techniques. 11G facility, database resident connection pooling. This was introduced with 11G release 1, but it kind of slid through quite a lot of the documentation and is not very widely used, and perhaps it should be. This is a pooling capability enabled within the database server. It reduces database machine resource usage. We have a fixed number of server processes, and that will count as the size of the pool. PGA is unbelievably limited. I can't speak from my own experience, But Oracle's claim for database resident connection pooling is extraordinary reductions in memory usage. Now, Oracle quotes an example in their documentation of 5,000 concurrent connections requiring 22 gigabytes of PGA running dedicated server, but only 615 megabytes using a database resident connection pool. So 500,000 connections, memory usage from 22G down to less than 1G. That's the sort of saving Oracle claims you can get. The scalability, I personally have not seen tens of thousands of concurrent connections. This is concurrent sessions as far as users are concerned. I've not seen tens of thousands, but Oracle claims to have reference sites on that sort of scale. And there is no way you could support 10,000 dedicated server processes on any normal computer. Just preemptive multitasking through 10,000 processes will bring Unix or Windows to its knees. When would you use this facility? Single-threaded clients. Apache, PHP, Forms. Clients where, as far as the end user is concerned, he's got his own session. And what we will do within the database is change that architecturally. So how do you do it? Well, you enable a connection pool. I'll enable one right. I'll enable the pool now. I prepared the script in advance because I don't like making too many typing errors. I'm configuring a pool at this point, and I'm being really, really aggressive with my pool. I'm having 4 processes, 4 sessions in the pool, minimum 4, maximum 4. Increment size doesn't really matter. Maximum lifetime, 300. 300 sessions in activity timeout, 300 sessions. So 300 seconds, just 5 minutes. So if a user takes a connection from the pool, he's got it for up to 5 minutes. But now I'm being really, really nasty. Max think time. I've cut that down to just 5 seconds. Then we start the pool. Start the pool. It's now running. I'm actually running in the threaded server, so it will be running within these. And if we were to run that again, no change here. But within the connection pool, within one of these multi-threaded services, there will now be another 4 threads running instantly for my connection pool. But never mind that. This, by the way, is all 11G. Now I've got my think time of 5 seconds. What happens if I connect? If I log on, and I'll just connect, demanding a pooled connection. So, SQL Plus, Scott Tiger. We have to go through OracleNet, of course. Nearly all of these new facilities will require OracleNet. I'll connect to Oracle and demand a pooled connection. Now, select star from dual. Right, as long as I've got the connection, as long as I'm using the connection, I can run code. But if I'm idle for 1, 2, 3, 4, 5, and then try to do it, I've lost my connection. So my connection pool, with a really short, aggressive time, has reclaimed the connection after just 5 seconds. My end user will now have to reconnect. Well, if it were a proper OCI application, of course, the reconnection would be totally transparent to the user. But because I'm using SQL+, I reclaim my connection, and then I can run a query again. SQL+, of course, does not use OCI appropriately. But the end result of this is within the database, I have a very small number of persistent connections that can be passed out to applications on demand. And it should be completely transparent to the application.
John, you touched on the answer to this, I believe, a little bit. Does this require any work on the client side?
Depends on how the client is written. SQL+ obviously loses the connection and doesn't re-request it. A client that's written in a more sensible fashion will be taking a connection from the pool. There's a specific OCI call to request a connection from a pool and then reuse it. And each time it wants to reuse the connection, it will check if the connection is there and ask for the connection again. And that means that the fact that it's been withdrawn, in my case after just 5 seconds, the client won't notice because it will re-request its old connection and will get it, provided, of course, the pool is sized adequately. It should be completely transparent. It should be completely transparent. When wouldn't it be transparent? Well, if you were using an older version of OCI, then there'll definitely be a problem. JDBC, if you're using a JDBC thick client, and the thick client would have to be linked with the 11G libraries, so JDBC thick client with 11G libraries, your programmers won't even know it's there. We'll take all the strain of connection pooling away from them. If they're not using an appropriately linked library, then they'll have to do a bit of work themselves. So it really depends on the container that your code's running within, but it should be transparent if the software is reasonably modern, running in a reasonably modern 11G compliant container.
Great, thank you.
Another possibility. Well, the database resident connection pool was introduced with version 10. Shared server, sorry, version 11 was when the database resident connection pool came in. Shared server goes back a lot further because Oracle has been aware of this problem of session handling for many, many releases. So shared server, I first came across it back with version 8. No, it was even there with version 7. And historically, we used to call it the multithreaded server. It had a lot of bad publicity. It was a bit awkward to set up. And to this day, many DBAs don't even think about using it. Now, I quite strongly believe that Oracle really wants you to use shared server. Oracle's been pushing us towards it for a couple of releases now. They've even made shared server requirement for some of the more recent capabilities of the database. If you're using protocols like HTTP, if you're using your database as an FTP server or an HTTP server, you will not be able to use those protocols unless you're coming through a shared server. I believe the Apex listener relies on shared servers. The remote scheduler system, that's a wonderful capability where you can run jobs on remote machines. That requires a shared server. Oracle wants you to use it. Well, what's the end result of this? As with the other facilities we've talked about, a vast reduction in operating system and machine resource requirements. That means you reduce the number of processes, you maybe reduce the number of memory. End result, huge increase in scalability. I have seen shared server environments where perhaps 50 shared servers could support maybe 5,000 or more concurrent sessions. So it's a similar scalability capability to the database resident connection pool that we saw previously. And this is nowadays extremely easy to set up. If you look at the parameters.
Yeah, that was the question coming at you, John. The old multi-threaded server was a bit tough to set up, and what do you think about it now?
With earlier releases, like so many DBAs, I had dreadful times. Now it's so simple. You can just do it freehand. I can alter system set dispatches equals, and choose a protocol and see how many I want. Dispatches equals 3, for example. Going back to the days of 8i, I would never have dared do that. I would have been testing. The slightest mistake, case sensitivity, white spaces, abbreviating protocol or abbreviating dispatches. Earlier releases were really, really sensitive. So there was perhaps a very good reason for people being frightened of the multi-threaded server. Current release, certainly from 10G and later, I find it very easy to set up. And the relevant parameters no longer seem nearly as sensitive as they used to be. The other critical parameter, by the way, is the shared server parameter. I have only one shared server at the moment, so I've got a rather silly ratio of 3 dispatchers and 1 shared server. The mechanism, I'm sure you're all familiar with it from earlier studies, even if you haven't used it, is that all your incoming sessions connect to the dispatchers, and dispatchers operate queues to route requests through to a pool of shared servers. So for 5,000 concurrent sessions, one might set up, say, 5 dispatchers and 50 shared servers. That would probably be a reasonable ratio. Then to use it, this really is, well, it reminds me of that previous question, this really is completely transparent to the client. All I do is demand a shared server connection, and I will have no idea from the client side at all of what is happening, because this is a persistent session. No problems with maintaining state. It's a persistent session. No problems with OCI. No problems with JDBC. It's completely transparent to the application. And all my users that come in through this mechanism log on. Get another session coming through. and then I can give it even another session. I will now have 3 sessions logged on, and whenever they do anything, they will be connected to their dispatcher. The dispatcher will put a job on the queue. The shared server will execute it. I've been told by SQL Server people, incidentally, that this is the way SQL Server has always worked. By analogy, a very similar mechanism. Certainly, the reduction in operating system resources and machine resources are fantastic. The savings, the context switches. Unix will no longer have to do preemptive multitasking across 1,000 processes. It will only have to preemptively multitask across 50 processes, perhaps. And that increases the scalability of the application enormously. I suppose I should mention that, like all pooling, this is a scalability thing more than performance. Typically, just to give you a warning, typically any one call to the database may be fractionally slower because there will be a couple of extra CPU cycles as the dispatcher enqueues the request and the shared server dequeues the request. I don't believe it's measurable, and certainly the benefits of scalability will far outweigh the possible drop of maybe a millisecond in any one call. Look into it.
John, fabulous stuff here. A couple of questions in the queue. This one ties back to the multi-threaded server. Have you, John, for the audience benefit, John is in the 12C beta program. Do you know if this multi-threaded design will work with shared server? Has that been tested?
I'm using the shared server at this precise moment, so you could say I'm testing it right now. My own opinion is that you're stacking up several things when you do that. If you think of the query I'm running here, looking at the processes, my dispatchers, let's see, dispatcher D triple, that's one of my dispatchers. There should be, let me put an order by clause on the statement, that might make it a bit easier to understand. Order by 1, right. There are my 3 dispatchers. Remember, I've configured 3 dispatchers here, 3 of them. My 3 dispatchers are in fact running within my threaded structure as threads within process 3263. My shared servers, I've configured only 1 shared server, but my shared server is running as thread 3322 within process 3263. So what I've done now is I've stacked up 2 levels of multi-threading. I've got multi-threading for the database, and I've got multi-threading for the sessions themselves. So yes, they do work together. Probably wouldn't make sense to do so. I think one would almost certainly want to use one or the other. Interesting question. I haven't thought that through.
Yeah, I see that. Probably not the best combination. John, a question in about TDE, transparent data encryption, shared server. Any implications with shared server and TDE?
No implications at all. The transparent data encryption occurs, assume we're talking tablespace encryption, that occurs during the path from buffer cache to disk when we encrypt, and from disk back to buffer cache when we decrypt. So the session itself, the server process, whether it's a shared server process or dedicated server process or pooled server process, will have no knowledge of the encryption whatsoever, because it isn't the session that's actually doing it. So we're okay there.
Very good. Is there a general rule of thumb? We might be getting a little out of scope here, but is there a general rule of thumb to determine the number of dispatchers?
Well, we could. One tunes. I would typically tune by looking at the queues. And if for your dispatchers you find you've got any queuing at all, if there's been any queuing whatsoever, and I haven't had I've had lots of queuing. One wait. I've had 1 wait, yeah. But in principle, as long as you don't have, as the queue call right now, there's nothing on any queue. If anything in this column is greater than 0 and increasing, then you're in trouble. And that's how I would tune. I'd probably start by taking 1 dispatcher per 200 or 300 and see if I get items on the queue. And if I do, there's a problem.
Very good, thanks. Yeah, the person who came back, our student with the TDE question was saying column encryption for TDE opposed to tablespace.
column encryption rather than tablespace encryption, the difference there is that the data remains encrypted in the SGA, which the tablespace encryption is clear text in the SGA. I still do not think, no, I can absolutely say there will still be no issues at all with pooling, any of the pooling, because the decryption will occur during when we fetch the data from the SGA back to the PGA in the session. So again, it's already going to be decrypted by the time it hits the session. Yes, I'm absolutely certain that TDE, whether it's column encryption or tablespace encryption, you needn't worry, pooling will not have any effects on that.
Wonderful. Thank you so much, John. Back to you.
Okay. There's another topic, the resource manager. The resource manager can also give you the ability to handle sessions much, much better. It can disconnect sessions, it can release resources. It would take a bit of a while to run through the demonstrations I have prepared for this. I think I'm going to give this one a miss. But if we look at the resource manager and how we configure it, when we configure resource manager directives, among many other things, we can configure a max idle time, a max idle blocker time. If we set either of these, or max idle time, we can disconnect a session completely if it's done nothing for a specified number of seconds. Idle, by the way, means either not in a query or not running a select statement. If you do an update and don't commit, we just go off to lunch for an hour, that doesn't count as idle. So within another way of controlling sessions, we can configure sessions to be disconnected automatically if they are doing nothing. If they are doing nothing and blocking someone else, that will be the example of taking a row lock and then not releasing it appropriately, we can have a much more aggressive setting for removing the session and rolling back the transaction. So we can quite straightforwardly disconnect sessions, and that will truly release resources through the idle time thresholds. Perhaps much more interestingly, there's a queuing mechanism. If we have, and this is not widely used, I suspect because when it was first introduced with release 9i release 1, there were Aura 600s all over the place. And as is so often the case, when something doesn't work too well in the first release, one tends to be a bit wary of it. But with 10G and later releases, I have seen the active session limit and the queuing mechanism work very well indeed. And just to forestall the question that's probably coming, yes, it works well with shared server. Now, for that we configure an active session limit. For each group, each resource manager group, we configure what we call the active session pool. So we might have, for example, in a data warehouse environment, no, not a data warehouse environment, an OLTP environment, where you also have people running queries. We all know the problem that one session running a bad query can kill performance for everybody else. It's a badly written data warehouse type query that's thrashing memory and CPU, particularly if it's using parallel processing, can destroy the performance need that your 500 OLTP staff really do need. We can control that by setting a pool. We can block requests completely. For a particular group, we can maybe block any job that might take more than a certain number of seconds to run. And that we would do with a switch estimate and the maximum estimate execution time. So if a query might be too bad, we can simply block it at certain times of day and let it through at other times of day. But most interestingly, the queuing mechanism of the active pool. We might have worked out that if maybe 4 people run queries concurrently, everything is fine. If more than 4 people do it, their sessions destroy performance for everybody else. So we set up a limit, active session pool, only 4. If 5 people try to run a query concurrently, the 5th one gets queued until one of the 4 active ones finishes. So we can handle session, oh, by the way, in that case, there is a wait event. So the session could in fact work out that it's being queued if it really wanted to. But once again, as a DBA, I can control the resources a session can take. In this case specifically, so that sessions that are too resource hungry will not impact on others. And the queuing mechanism means the end users, their jobs will still run, but they'll be delayed by a few seconds until resources become available without impacting too badly on other sessions. A very powerful capability, perhaps not as widely used as it should be, maybe because of the historical reasons of the problems when it was first introduced. I should mention, by the way, at the bottom of the slide, profiles, of course, are also a way of doing things. The older profile mechanism that dates back many releases does also give you certain amounts of control over sessions. If I were to take, say, a particular resource, and its limit, so we can, within the profile mechanism, we can also control what sessions are allowed to do with very, very crude limits. We can here, we can restrict, well, we can disconnect people after a certain amount of connect time, or need a certain amount of idle time. We can attempt to control how many concurrent sessions people can have. We can control their CPU usage. So there are things you can do with this older mechanism to control how many resources sessions can take up, and therefore the impact they have on other sessions. But unfortunately, it's extremely limited because it's all schema-based. As I'm sure you're aware, we assign a profile to a user, and then within DBA users, we can detect each schema name has a particular profile. And unlike the resource manager, there's no way to switch this dynamically. And of course, in any large-scale database, you might have 5,000 users logging on as user apps. So profiles, yes, they're there. I mentioned them for completeness, but because they're purely schema-based, they're really too limited for serious work with managing sessions and resources.
John, is the active session limit a 12G feature?
No, it isn't. This, I think it 9i release 2, if I remember correctly. It goes back a long time, but wasn't too reliable with earlier releases, which may be why people are not so familiar with it. Okay, well, what I've covered, I hope, is an idea of the problem that I see with sessions quite often. Too many sessions, too many idle sessions, too many log-ons, too many log-offs. Too many idle sessions, more likely. Connection pooling, not implemented correctly by programmers. And all of these things come together to cripple the performance of the hardware and the operating system. Then I tried to outline a few techniques. Well, if we could upgrade you to 12C, that might be the best way to do it. But we can't do that for a while yet. It isn't on general availability yet. But we can use database resident connection pooling. We can use shared servers. We can use the resource manager. And if we look at the pattern of session activity on your databases, we may well be able to find situations where performance is degrading not because of bad SQL, but because of bad session management. Then we would attempt to construct alternative session models and always, always, always go for measurable improvements to demonstrate that you're getting through more transactions per second, that your workload is being accomplished with lesser DB time, giving the option perhaps to downgrade your number of CPUs, reassign your Oracle licenses, and so on. And we would hope to be able to measure that. And what are the next steps? Well, what I've spent is about 40 minutes talking about just one of Oracle's top 10 mistakes. And never forget, there are other 9 to go. So unless there are any questions, or if there are any questions, I'll pass you back to Dave now.
Great. Yeah, we got some questions coming in. Please put your questions in the chat for us, folks. I'd like to remind you, in response to one of the questions, John originally showed us that the 20 log on and log offs took approximately 28 seconds. But then when he enabled the multi-threaded database with parameter threaded execution equals true, what took 28 seconds before went down to 15 or 16 seconds. So dramatic improvement in performance there. John, can you remind us what that was static parameters you bounced the database, make that happen?
Oh yes, it was static. No, I cannot imagine how anything like that could ever be done dynamically.
Of course, of course. Very good. So the background processes, we didn't see a one-for-one relationship. When we did the process status command in Unix, we saw that the background processes were running as threads. So less less background processes or processes, but more threads. So a lot less context switching on the operating system side, which I guess would really be the main reason for that fantastic improvement in response time of those log on, log offs. Okay. Okay. Little scope. How frequently should we collect stats on production? Assuming you meaning object stats. Boy, we talk about that endlessly in our SQL tuning class. John, do you want to say anything about that? How frequently should we collect stats?
That's to what we're talking about here. Clearly, if one were to enable the multi-threaded database, the operating system statistics would change dramatically. Now, how frequently should you analyze your database? Dave and I always give the same advice when tuning, which is to enable the Oracle automatic job, which runs every night. And only if that is not doing what you think it needs to do, then gather statistics manually as well. But generally, I would try to configure the automatic stats collection job. Configure that so it will do things automatically. The configuration would typically be things like the percentage of objects to estimate and the histograms to build up.
Okay, great. So, folks, you are welcome. Thank you, Mayank. So, we do hope you keep us in mind for your Oracle project needs. John and I are available for on-site or remote consulting. You have your email addresses on the screen right now. Gary at SkillBuilders, who's our business manager here, and mine's Dave, and john.watson at skillbuilders.com. And we certainly would like to assist you in any project requirements you have. We also can help you with training, and we are an Oracle partner, so we can help you with Oracle licensing. And we love to save you money by showing what options you don't actually need. So we hope to have an opportunity to save you some money sometime. So skillbuilders.com/Oracle is where you'll find John, myself, and the rest of our team.